Hello, everyone. It's cloudy and cold out there. You can't go out and observe. So that means it's time for another season of online viewing sessions with the Kalamazoo Astronomical Society. So welcome back, everyone. It's been not what 9 months since our last online viewing session. It is great to have you all here tonight. And we have a pretty good lineup for you tonight. Lots of cool deep sky objects to check out. But before we do, let me just kind of give you a little bit of intro to the online viewing sessions and the remote telescope if this is your first time attending. So I'm going to go back and share the screen here, and we're just going to jump right into it. So again, welcome to the online viewing session for November 15th, 2025. And so here you can see Peishi Observatory. We'll show you a bit different photo here in just a second. And see if I can get this thing to advance. Here we go. So this is the location of Peishi Observatory. Just look for the red star there at the lower right in the southeast part of the state. And that's where Arizona Sky Village is located. So, of course, Arizona Sky Village is the home of the KAS Remote Telescope. So let me give you a little tour of Arizona Sky Village and also the nearest town, if you can call it that, called Portal, Arizona. So this is the Portal, Arizona post office. You can see the zip code is 85632. This is the Portal Store Cafe and Lodge right in downtown Portal. And that pretty much concludes our tour of Portal, Arizona. That's pretty much it. It's a town of roughly 100 people or so, very small. Probably a good chunk of those residents live here at Arizona Sky Village. There's lots of course, ranches and stuff nearby as well. But that's pretty much it out there. It's not you can barely even call it a town. It may be a village or something like that. So here's where Arizona Sky Village is located, again in Arizona, but this is at night. This is the light pollution map, and you can see the nearest sources of light pollution are several hours away. Just west of Arizona Sky Village is national forest land, like 1.78 million acres of it, and you can't really develop national forest land, so the skies above Arizona Sky Village should stay dark for a long time. So that's a lot of the reason why people have built houses and observatories out there, and that's a big reason why we put the remote telescope out there. So on the Bortle scale, you can see where we are with the X here. It's kind of a Bortle 2 site, but maybe kind of the upper echelon of a Bortle 2 site. You know, one's like pure black, and two are kind of various shades of gray. Well, we're kind of the upper shade there. So it's not quite a perfect dark sky site, a Bortle 1, but it's pretty good. You know, it's much better than anything we get, at least in the lower peninsula of Michigan. And maybe to get something like a 2, you have to go up somewhere in the UP. But there's a lot of trees up there, so it's hard to find a really, really good spot for observing. So here's a lot better view of Peishi Observatory. It's basically a 20 by 20 roll-off roof observatory, and just kind of sticking up there, you can see the KAS Remote Telescope. So there it is. And the observatory is owned by KAS member Mike Patton, who is out there right now. I don't believe he's attending just yet, but he's currently out there, so he might chime in later. We might see him later. And so years ago, boy, going on 15 years or so now, he approached us at a meeting and basically said, hey, I'm going to build this house and eventually an observatory. If you guys can help me with technical aspects of my observatory, I'll let you put a remote telescope out there. So we thought about it, we decided to do it, and we did like a massive fundraiser, and we raised like $122,000, 60% of which was through member contributions. So we're very proud of that. It was probably it was the most successful fundraiser in our entire history. So we did much better than we ever anticipated. And so on the back here, you can see a couple devices. This is the weather monitoring station on the far left, but kind of at the peak of the roof there on the very back of the warm room, or the cool room in the summer, is our all sky camera. So this is the Peishi all sky camera. By the way, Peishi is what is it? Apache, I believe, for Nighthawk. If Mike Patton's here, we'll get some clarification on that later. But this is our all sky camera that allows us to basically monitor the weather out there, see what the skies are really like above Arizona Sky Village instead of just looking at a satellite. So as some of you might know, last season we upgraded the all sky camera. We got rid of the old S-Big camera with the tiny little CCD chip, and we upgraded in kind of a major way. We now use a ZWO ASI 183 MC camera, which is, a really good planetary camera. Not quite deep sky camera, but it's a really good planetary camera. But we attached it to a Fujinon 2.7 millimeter f1.8 fisheye lens, and you can see kind of what the contraption looks like on the inside there. So let me share another screen here. I'm gonna try to get to my web browser. I don't think I opened it yet, but that's fine. We'll go, if I can figure out which one it is. It's got to be one of these. Nope, that's not it. Why, do I even have the web browser open? It's not. Let me try to share my entire screen there and see if I can go to the web browser. It's open. I don't know what the deal is. Okay. Oh, here we go. So let me double check that. Okay, there we go. So we'll share it like that. So hopefully you can see that there. So here's the all sky camera, and this basically runs 24/7. At least between October and June every year. We shut everything off during the summer. I can talk about why later. But if you ever want to check out the all sky camera on your own, you can go to a remote telescope. Of course, we have an introduction to the remote telescope. If you want to learn more, of course, I'm happy to tell you everything I know here tonight. You can learn more about the current set of instruments we have, but more on that later. If you are a member, or you're a researcher or a student, and you're possibly interested in using the remote telescope, you can check out that link. If you are signed up to use the remote telescope, you can make your requests for observatory time here. And then finally, we have the Peishi all sky camera. And if you pull that up, it takes you to this page right here. So this is the current sky above Arizona Sky Village. You can see it's November 15th, 2025. And this view is about 8 minutes old now. And the camera refreshes itself every 4 minutes or so, because we have the camera take an image every 4 minutes, but the camera takes pictures, and the time the browser, your browser will reload, are never really in sync. But we try to do that. Let me try to hit reload there and see if we can get maybe a more updated view. There we go. So now this is only about 5 minutes old. So that's a little more recent. So you can see we get new images all the time. And it looks like a pretty clear night. It's not quite fully dark yet, which is why I'm kind of killing some time here. Because it still takes a little while longer to get dark out there. But can kind of give you a quick tour. It's kind of hard to see along the horizon here. But right here at the upper right, that's Mike Patton's house. And sometimes you can actually see the roof open. I don't really see it too well tonight, but sometimes you see the roof open. And then you can see some of the other houses. This is like Mike's immediate neighbor nearby. And way off in the distance there, you can see some lights. That's full-time resident Rick Benno's house, who has a very nice observatory with a 24-inch plane wave. But, there's not too much on the horizon. There are some distant lights for other neighbors, but it's a pretty wide open, kind of sparsely populated area. And of course, the thing that really catches your view is this contraption here. It looks way bigger than it really is, but this is basically a bird perch right next to the all sky camera, because of course, I guess birds tend to look for the highest point to survey for prey or something like that. And they kept landing on the dome of the all-sky camera, and sometimes they would do their bird business on the all-sky camera. So to kind of alleviate that, we put this bird perch nearby. And occasionally on like our social media pages, if I happen to capture one, I'll post images of cool birds on the perch here. But we don't see them too often. They tend to fly away pretty quick, especially when you only take an image every 4 minutes or so. So let me give you a quick tour of the night sky above Arizona Sky Village right now. So basically, this is due north right here. Yeah, you can't really see the Big Dipper. I think this is probably the handle of the Big Dipper right there, but from their latitude, like 32 degrees, the Big Dipper is not circumpolar like it is here in Kalamazoo, but right here is this little speck right there, and that is Polaris, the North Star. So you go straight down, and that is due north. So obviously this is south, over here is west, and over here is east. So kind of like a star map, east and west are backwards here. So basically everything is rising in the east over here and setting in the west over here. And you can see the summer triangle. You know, we're kind of way into fall now, but we still have the summer triangle visible. We have the stars Vega, Deneb, and Altair. It's clear skies above you right now. You can walk out and see the real thing. But here's a quick image of it. And of course, Vega is part of the constellation Lyra the Lyre, which is kind of like a harp type instrument. And if you look really close, you can see a isosceles triangle and a parallelogram. And that's basically the shape of Lyra, kind of like a isosceles triangle attached to a parallelogram. But you can imagine like strings of a harp type instrument here. So there it is. It's a pretty small constellation. Then we go over to Deneb, and our first target tonight is hanging just off Deneb here. Those of you that really know the sky probably know what I'm talking about. It's an object we've done before. We don't do it every season, but we're going to do it tonight. That's what we'll lead off with. So Deneb is the tail of Cygnus the Swan. Oh, we just got a new image. And it's also the top of another asterism called the Northern Cross. So this is like the cross here. It starts at Deneb, ends at Albireo down there, and there's a couple stars for the other side of the cross. But this is the tail of the swan. This is her head. There's kind of like a band of stars there for the head, and it ends right there for the head, Albireo. Very nice optical double. It's not a true binary system. Then from Satyr here, we go out to a couple stars for the wings here, and another kind of group of stars over here, like a little line of 3 stars for the tips of the wings. There's like, you know, wing here, tail, head. So it's kind of flying in this general direction. Then we go down to Altair and Aquila the Eagle. And you can make out this little triangle again, another triangle attached to a bigger triangle. This is the body of the eagle. And there's like a straight wing here, a bent back wing there, and a couple little tail out here. So the eagle's flying in the opposite direction. And then, of course, going right through the summer triangle is the Milky Way. You can just barely make out the central bulge here. It's starting to set behind the Chiricahua Mountains here. And so you can't really see it. You know, summer is well behind us, so you really can't see the best part of the Milky Way anymore. But you can really see the Great Rift here, this dark lane in the plane of the disk of our galaxy. It goes all the way down toward the central bulge, all the way up here till Cygnus. So we call this the Great Rift. And if we kind of follow the Milky Way, starting along the Great Rift and then kind of continuing here, we come across Cassiopeia, the Queen. And over here, you can see Perseus. And of course, Perseus kind of looks like a wishbone. And at the end of the long end of the wishbone, we have the Pleiades here, which is a target we often do during remote sessions. But we're going to save that for another time if you want to see the Pleiades through one of our telescopes. And so the summer triangle is basically the dominant asterism of summer. The dominant asterism of fall is the Great Square, which is right here. So there's the Great Square in Pegasus. And actually, these three stars belong to Pegasus. This is the back of the horse, the winged horse. And there's kind of like this triangular head here with the star Enif. There's a nice globular cluster right there, which we've checked out before, but we're not going to do that globular cluster tonight. We're going to do a different one. And so there's the head. The horse is kind of upside down in the sky. This is like the chest of the horse, I guess. There's like a front leg here and a front leg here. But imagine it flying upside down. But this star here, called Alpheratz, this is the head of Andromeda, which is two arcs of stars. Kind of, you start from Alpheratz, there's one there, one there, one there, then kind of another fainter row just above. It's a lot fainter. And if you look very closely, there's a little smudge right there, and that is the Andromeda Galaxy. Again, a target we do every season, but we're going to save that most likely for next month. I know I'm leaving you hanging here and exactly what we're going to do tonight. And so right below is part of Pisces, but the circlet here is the head of Pisces, and it kind of goes down here and up here, but that's a little hard to see on this scale, and it's not fully dark yet. It might become a little more prominent later. And then we have other constellations over here like Triangulum and Aries, which I think is here. It's a little hard to tell from this angle, but right behind the perch here is Capricornus. And maybe later we can just start to see Taurus here. This is Aldebaran and the Hyades and the face of Taurus, the bull. But as we get toward the end of the night, we should start seeing some of the winter constellations besides Taurus, like hopefully Orion, by the time we get there. All right. So we're back here. And let me tell you about the first telescope we're going to use tonight. The first telescope we'll use is our Takahashi FSQ 106 EDX3. I won't bother to go through all the details here, but the short version is it's basically a 4-inch refractor with a 530 millimeter focal length, so focal ratio of f5. So it's a pretty fast telescope. And you can see we've made some modifications to it. It doesn't have the stock focuser on it, but it has a Moonlight Nightcrawler 2 focuser. Very, very excellent focuser. So that is the telescope we're going to start with tonight. This is our wide field telescope. Has a much wider field of view than the 20-inch does, which we'll finish up tonight. If you've ever attended the online viewing session before, you know we always start with the Takahashi, and we always end up using the 20-inch. And the current camera that we have on both telescopes are a pair of SBIG STX 16803 CCD cameras. We're going to hopefully replace these in the pretty near future, probably early next year toward the end of our viewing season, I hope. So, but we're currently using this camera. It's still a very good camera, but you know, CCDs are getting pretty old, and newer cameras have much less noise to them compared to modern day cameras, but still we've gotten some excellent images off this camera. So it has a very big chip, much bigger than most other full frame CMOS cameras you can get today. It's nearly 37 millimeters square, not like the 36 by 24 type format that most full frame cameras have. It's a big, nearly 37 millimeter square chip. It's only 16.8 megapixel, but you know, for astronomy cameras, you don't want a whole mess of megapixels. You know, the more pixels, the more noise you might have. But it's getting better and better with newer cameras. So all things considered, it is still a really, really good camera. Okay, so I was hoping to show you the inside of the observatory with our PEC cam, but we recently, or toward the end of last season, we upgraded to a new camera, and I don't have it quite visible on the website yet, or at least via a web page. I have to use an iPad to look at it, so it's not something I can easily show you, but let me go ahead and set up our first target here. So I'm going to go back to the web browser. Click on this tab here. I can close that. Click on this tab here. Yep, we're all set up. And this is ACP, the Astronomer's Control Panel, which is what we use to control the remote telescope via the internet, because no, I am not at Arizona Sky Village. I am here in Kalamazoo, Michigan. So this gives us easy access to the remote telescope in Arizona. So I'm going to scroll down here, and I'm going to type in NGC 7000. I'll go ahead and hit get coordinates, but I'm going to modify these slightly because I always like to frame it a little bit differently than ACP would automatically. And we've done this before, so bear with me here. We'll enter the coordinates that I have written down by me. And I mean, they're nearly the same. Oh, what'd I do? What did I do? Forgot a decimal. Okay. Should be able to put in the whole thing. Yeah, there we go. And then 34 here. Change this to 16.68. And we're going to use the hydrogen alpha filter. And let's go crazy. Let's go ahead and do 10 whole minutes. So we'll have plenty of time to chat afterward. I've already focused. It'll auto guide automatically. So let's go ahead and acquire the image there. And pretty soon here, the telescope will slew. I wish I could show it to you, but eventually we'll get the new cameras all set up so we can share them with the general public here, but we haven't quite gotten there yet. Okay, so that's off and going. And let's talk about what we're going to check out. So yes, indeed, our first target of the night is NGC 7000, called the North America Nebula. Now, if you're new to astronomy or maybe know someone that's been doing this a while, you may have heard some people say North American Nebula, but that is incorrect. The correct way to pronounce that, the correct name is North America Nebula. You'd be surprised. I hear a lot of members that have been doing this for decades say North American Nebula, which is wrong. It is North America Nebula. Okay, so you can see little different coordinates than what I typed in, but it's pretty close to this. It's only off by a few minutes here, and maybe 3 minutes here, so it's only, it's very close. Don't let the magnitude of 4 fool you. This thing is huge. I mean, the full moon, for comparison, is nearly 30 arc minutes. So this is 120 by 100 arc minutes. This thing is big. So that's why we're using the Takahashi. And even though it has a magnitude of 4 here, an apparent magnitude of 4, its surface brightness is very, very low. But I've seen it in binoculars fairly easily from dark sites. And you can also use a UHC filter with a wide field telescope, like our Teleview telescope in our observatory here in town. And you can see it's at a distance of about 1,600 light years away. So I already kind of pointed out its general location on the all-sky map, but here's a screensaver saved from Starry Night, the desktop planetarium program Starry Night, and you can see I have the target right on NGC 7000, the North American Nebula. So it's just off Deneb. It's located just 3 degrees east of Deneb and about 1 degree west of the 4th magnitude Xi Cygni. So we can actually see a little more detail in this chart here. So that's the general location of the North American Nebula. And you can also see there's another nebula nearby. Oh, let me see if I can turn my laser pointer on. If I can remember how to do that there. Let's see. No, that's not it. Where is it? Let's try that. Well, here it is. So I can't find my laser pointer. It's down here somewhere. It's got to be one of these, but whatever. Okay, so again, there's Deneb, And you can see right even closer to Deneb is IC 5070, the Pelican Nebula. And so that's why I've entered custom coordinates so we can get a really good framing of both nebulae together, because they really make a striking pair when seen full frame with the remote telescope, or at least the Takahashi component of the remote telescope. So yeah, this thing is like 4 times the diameter of the full moon, at least just the North America part alone. It was actually discovered by William Herschel on October 24th, 1786, or even by John Herschel before 1833. It was first photographed by someone named Max Wolf in 1890, and he's the one that gave it its popular name, the North America Nebula. There is a 10th magnitude open cluster, NGC 6997, which roughly marks the location of Ohio. They don't show it on the Sky Atlas here, and I should mention this is a scan from Sky and Telescope's Pocket Sky Atlas. If you don't own a copy, I highly recommend it. This is specifically from Sky and Telescope's Jumbo Pocket Sky Atlas, which is an excellent atlas. So I highly recommend it if you're looking for a decent atlas. I know a lot of people use GoTo on their phone today, but it's still good to have a good old-fashioned atlas to look at once in a while. And I recommend the one from Sky and Telescope. Okay, so let's go back to ACP. We'll see how we're doing here. And we have a guide star. We are guiding. So you can see we're doing our 10-minute exposure. We have a guide star, and we're off and running. And while we're doing that, why don't we go back to AnyDesk here. So I use AnyDesk to connect to the computer out west so I can see what's going on with the computer here. And so you can see the guide star. We're using a program called Maxim DL for our auto guiding and imaging, an ACP controlled Maxim. And we don't really need Focus Max here anymore, but this is what I use to focus the telescope before we started here tonight. So we can actually collapse that, make that go away. But let's check on the weather out at Arizona Sky Village. You can see it's clear, which we confirm with the all-sky camera. It's very calm. The wind is only 2.2 miles per hour, so a really good night for imaging. And I have no idea what the humidity in Michigan is right now, but I can guarantee you it is nowhere close to 34%. It is significantly higher. And really, for Arizona Sky Village, this is kind of a humid night, 34%. I've seen it in the single digits many, many times. And the ambient temperature out there is nearly 65 degrees. So it's a really good night out there. Not too cold, not very windy, thank goodness. And I mentioned in the email that I sent out to those on the online viewing session email list, or the member list, that there was rain in the forecast tonight, but that was earlier in the week and it has long since gone away. So it should be a great night for imaging with the remote telescope. And you can see this program here is called M1 Oasis. This is what allows us to roll the roof on and off the building. So, because remember, it is a 20 by 20 roll-off roof observatory. Okay, so we still got roughly halfway to go. So I'm going to stop sharing here and let me give everyone the ability to unmute themselves. There we go. Wait. No, I had it checked down the whole time. Okay, I'm going to change it to gallery view there. There we go. So hopefully you can see me a bit better now. And while we're waiting, we have, again, roughly 5 minutes to kill. If anyone has any questions or comments or just wants to say hi, now's a great time to do it, because I'm out of material, folks. How's the weather where you are?
This is Ann Murphy from Raleigh, North Carolina. And actually, it has gotten warmer. So we were in the 70s today.
Wow. Yeah, we had a cold spell earlier in the week where we actually had snow. I think we got, what, maybe 3-4 inches of snow, but it's since gotten more warmer now, thank goodness. Anybody else?
Richard, Chris Shoemate, The Woodlands, Texas. I was out viewing a while ago with binoculars, and the conditions are great here for us. It was 80s today, but it's now down in the 70s. A fairly still night, no wind, and it was a pleasure. And this joined, and good to be here again. Thanks for hosting this.
Yeah, thanks for attending. So I see, can look through the chat here. Sometimes I tend to forget about the chat, but yeah, we see, oh, we have somebody from Italy joining us tonight. So welcome all the way from Italy. That's wonderful. And of course, Ann mentioned she's from Raleigh. We have Steve from Rochester, Minnesota. Ann grew up in Kalamazoo, so you know how rotten the weather here can be. We have Eric Sullivan from Marshall. Eric, you got to renew your membership eventually, by the way, just kind of FYI. And yep, we have Kevin from Maine. We know Kevin. Somebody from Loveland, Colorado. Oh, we have our another visitor from London. I know we had another gentleman that regularly attended online viewing sessions. I'm not sure if he's with us tonight, but we have somebody else from the United Kingdom, which is great. Apparently there's thunder and lightning in upstate New York. Somebody from Toronto, and so on. So Cheyenne, Wyoming, welcome. Oh, Las Vegas. So I'm glad you're joining us and not out gambling. Of course, probably only the tourists do that, right? All right, so shall we check in to see how our progress is doing? Okay, here we go. We're guiding the way. We're getting there. Oh, and maybe while we have a few more minutes, I'll mention some news that broke over the summer. I was going to mention this when we were talking about our equipment, but it starts out kind of sad. One of our members who first joined in 2007 passed away. We never really saw him very much. He attended like the first year, but he had to take care of his elderly mother who lived to like the age of 103 or something like that. I can't remember the exact age, but she definitely lived into the 3 digits. So we never saw him very much because he had to stay home constantly with his elderly mother. He passed away earlier this year. His name was Fred Dutton, and Fred had almost the identical telescope that we have in the observatory out west. He also had a 20-inch plane wave, but with a Pyrex mirror as opposed to a quartz mirror, which is what our telescope has. So our telescope was a little superior with a quartz mirror with its better thermal properties. And so he donated his 20-inch to the KAS, along with a very nice Paramount ME, the previous model of our Paramount that we now have. And he also donated all kinds of other equipment and his observatory. And so we're in the process of liquidating all of that because some stuff we did keep, most of it we're going to sell, and we're going to use a lot of the proceeds to upgrade the remote telescope, kind of modernize it a bit. And there's certain things we've had technical issues with over the years that we're going to try to improve. So again, expect big things ahead for the remote telescope. We're going to really do our best to improve it. And it looks like we're just about done here. I don't know why ACP always goes 5 seconds over. It doesn't do that on Maximum. It only does it on ACP. And now the image will download from the camera. It processes a quick thumbnail, but it takes a second to process the larger view. So I'm going to wait to hear the bonk bonk from the computer out west, and then we'll click on it, and then we'll check out our first target for the night. And as always, when I release the larger version of the image, I ask that everyone unmute themselves so we can hear your natural reaction. All right, here we go. So we plate solved. It found 26,000. Where'd it go? 26,539 stars, 14,406 of which were catalog stars. And so it solved 360 stars. All right, so here we go. It's done. Are we ready for the first image of the night?
Sure.
Hit me.
All right, so here is NGC 7000. Ta-da!
Ooh.
Wonderful.
Wow.
Very good picture.
Exciting.
Great. Wow.
Looks like it's got the Bermuda Triangle there off to the right.
It's a very good picture.
Remember, that's live from the telescope too. You know, quote, live. That's not on file. We just took that.
Comprendo.
All right, so the North America part has a diameter of roughly 50 to 100 light years, depending on its exact distance. And it's basically interstellar dust that helps to shape the nebula. So there's probably the most guilty part is this big dark nebula here that makes the Gulf of Mexico here. So that really gives it its shape.
Richard, could you talk about the cardinal directions on the picture we're looking at?
I believe north is at the top. I think it's pretty well north-south aligned. Somebody can correct me if I'm wrong, but I'm pretty sure it's roughly north-oriented here. Maybe a little more over here. I think it depends, because it does tilt a bit in the sky. But I'm not sure of the exact directions. But I'm trying to think about it in my head. We can go back to the All-Sky Atlas, but I'm not quite 100% sure. But that's my best guess. Someone can correct me if I'm wrong. So the dense portion resembling Mexico and Central America along here is known as the Cygnus Wall. You can see kind of like a pillar here and this big dense kind of wall material here. So Deneb, which is just out of the field of view here, is the possible source that lights the nebula. And the star and nebula are about 70 light years apart, which seems a great distance. I mean, 70 light years is really far away. But Deneb is a massive star, much, much more massive and luminous than the sun. So that's still doable, considering how powerful Deneb really is. And then here we can see the Pelican Nebula. You can see the eye of the pelican and kind of its beak and mouth. So that's composed of IC 5067 and IC 5070, which is, and so this kind of helps. This is southwest of the North American Nebula. So this direction here is southwest. That kind of helps a little. But even though they look like they're separate objects with kind of a dark lane between them, they're all part of the same giant molecular interstellar cloud. And don't forget, I will give you a link at the end of the session tonight that will allow you to download all these images. But first, I have to download them myself and give them a bit of processing. And the versions that you will have will be full resolution. So you can zoom in a lot more than we can here, because this is a reduced version of the actual final image. So you'll be able to zoom in a lot closer and get a lot more detail later. But this is the best we can do right now. All right, so we're going to go ahead and close that.
Full picture.
And we're going to go to our next target here. I guess I'll just type in one of the, this thing has multiple NGC numbers, so I'm going to pick the first one listed here, 6960. We'll just get coordinates so I don't have to type as much because I'm lazy. And we'll kind of get rid of that 4. Put in 1. And yeah, I'm using custom coordinates again just because I want to frame it just right. It worked pretty well last time, so I'm going to do it again. And I got to change that to 1. We'll change that to 0. Try to recycle the 3 there, save some photons. Aha. And 41.6. It doesn't have to be so particular. And we'll go ahead and stick with 10 minutes at H alpha. And we'll go ahead and hit acquire image. There we go. And off it goes. So what are we going to do next? Oh, and before we do next, I forgot, is occasionally I do like to show some pretty color pictures, but only if they're from the remote telescope. So these are images of the North American nebula, specifically the Cygnus wall with the remote telescope. This was taken by one of our members a few years ago. So this is with the sulfur and hydrogen alpha and O3 filters with various exposures that you can see here. So basically did 41 20-minute shots for a 13-hour, 40-minute image with the remote telescope. So this is a narrow band image. The next one is too, but for the next one, there's only basically hydrogen alpha and O3, no sulfur in this version. You can see they're kind of going back and forth here. They're very similar, just a little different filters and image length and artificial colors here. So this is with the actual remote telescope. Only time we show color pictures like this. Okay, so here's our next target tonight. And you can see I picked the NGC number we're not showing here. It has several. There's NGC 6960, 6992, and 6995, which is, I think, more commonly referred to as the Veil Nebula. But when we look at the entire thing, all the NGC numbers, I call it the Cygnus loop, which is, you know, not just me, but other people do as well. But I think that's a much more appropriate name when you talk about the collective whole of this object. And so you can see the coordinates are very similar to what I just typed in, just a little bit different to frame it differently. This thing is probably actually easier to observe through a telescope than the North American Nebula, because it's still pretty big, but it's thin. So it is about 7.5 magnitude. So it's pretty easy to do with the telescope, but again, a UHC filter does help. And it's pretty big, 60 by 8 arc minutes. Not as big as the North American Nebula, but still 60 arc minutes is 2 full moons. So that's why we're using the Takahashi. It's big, and it's over 1,700 light years away. And this does have other names. So yeah, the Cygnus loop is best known as the Veil Nebula, but I've seen references to it as the Cirrus Nebula or the Filamentary Nebula, because it does have a very filamentary structure. But by and large, most people will refer to it, you know, usually as either the Eastern or Western Veil, but collectively, I like to call it the Cygnus loop, as many people do. Here's the other component. Oh, I forgot I had this here. Is NGC 6960. The Witch's Broom, and I believe this is, I can't look at my notes here the way I have it here, I believe this is the Eastern Veil. So again, correct me if I'm wrong on that. I get those mixed up all the time. And we previously looked at the North American Nebula, but now we're just over here, kind of in front of the wing, I guess. And of course, I have all the stuff in the way, but you can see part of it here, but I have it centered on the very center of the whole loop. It goes from over here to over here. So again, it's very, very large in the sky. Not especially hard to find, at least the general position. But again, you need like a UHC filter to really bring this thing out, if you've never tried to look at it in reality before. So it's basically located 3 degrees southeast of Epsilon Cygni, and 4 degrees west of Zeta Cygni, right between the two wing stars here, again. Can't find my cursor. There it is. So there's Epsilon, there's Zeta. And parts were discovered by William Herschel September 5th and 7th, 1784. These include the main part, 6960, which is the Western Veil, now I remember, or the Witch's Broom. The Western Veil Witch's Broom, NGC 6960, and then also 6992 and 6979. which is what I have in my notes here, but this is basically the eastern veil, or I'm sorry, yeah, the eastern veil. It's easy to get those mixed up. Okay, so obviously this is a supernova remnant. This is not a planetary nebula. This is a supernova remnant. So we have plenty of time here. So let me kind of explain in a nutshell how these things form. Okay, so all stars, it doesn't matter what size, the big ones, the little ones, they all spend roughly 90% of their lifetime fusing hydrogen into helium in their core. That's what stars do. They fuse hydrogen into helium. So for the longest time, this helium is like ash in the fireplace. It's just left behind. It doesn't do anything because the core of the star is not hot enough to fuse helium, which requires a core temperature of 100 million Kelvin. It's insane. But eventually, the gas tank is going to run dry. The hydrogen in the core is going to be gone. And so what happens for a short time is the core of the star begins to contract, where gravitational energy is converted into thermal energy. The core gets hotter and hotter and hotter and hotter, and eventually it gets to 100 million Kelvin where helium fusion begins. But as the star begins to shrink above it, because the core is contracting, there is a hydrogen fusion shell around the helium core. So when the core begins to fuse helium into like carbon and oxygen, you have helium fusion in the core and then hydrogen fusion in a shell above that. Let's skip ahead here, because eventually, when the helium runs dry in the core, massive stars will begin to fuse carbon or even oxygen. The sun can't do that. With helium fusion in the core, that's it. The sun's done. It becomes just almost pure carbon and oxygen nuclei. But more massive stars can go beyond that. And then you get this successive line of various shells. You may have started with a helium core here and then a hydrogen core above that. But with the really massive stars, you can have a hydrogen fusion shell, a helium fusion shell, carbon, neon, oxygen, silicon, and then finally you get to an iron core. Now, during this time, the star will kind of expand and contract, expand and contract. It might shut off layers of itself, kind of like a planetary nebula does, but there's still plenty of the star left. But when you get to an iron core, that can last maybe 1/10 of a second, because iron fusion doesn't release energy, it absorbs energy. So remember, the star is trying to balance the force of gravity, right? And so eventually, the iron core works with gravity and basically crushes the core, either into a neutron star or maybe a black hole, while the outer layers of the star implode and rebound into a supernova explosion. So that's what's happened here. Is this massive star, this one-time massive star, has since blown up. And again, you can see maybe if this were a 25 mass solar star, you can see it could spend 7 million years doing hydrogen fusion. And silicon fusion lasts only a day, because the more complex the element, the more protons it needs. And so there's less fuel for each type fusion element. So there's less and less in the gas tank as you go down here. There's a lot of hydrogen, but there's very little silicon to fuse because it takes so many protons and neutrons to make silicon. So it doesn't last very long. But these all release energy. Iron fusion absorbs energy, which is really, really bad for the star. And then it basically does, this. Add your own sound effects if you want. Blurry. So eventually you get to these wispy embers around it, and that's what we're going to check out here. And obviously, you may have heard that we are star stuff. Carl Sagan famously said that we are the stuff of stars, and there is a lot of truth to that. So you can see dark blue is exploding massive stars. All these elements with dark blue come from massive stars exploding, or some come from exploding white dwarfs as a type 1A supernova. And, there are other ways the rest of the elements can form. So yeah, we are the stuff of stars. We would not exist if stars live forever. They have to die so that we may live. Okay, let's see how we're doing here. We'll go back to ACP. Oh, I killed a lot of time there. Look at that. Pretty good job, huh? So we're really trucking along there. While we're waiting. Oh wait, I don't have to do that. Let's go back to the all sky camera. Ah, look, a cloud. You gas. It looks like a giant, long-headed monster. Oh my goodness. So maybe Arizona Sky Village is under attack. But not too much has changed. You can see Taurus has gotten a little bit higher. But we are imaging right around here. You can kind of see the North American Nebula here, but you can't really see the Cygnus loop on here. Even if I do a right-click here and go to another window, we can really zoom in here. You really can't see it. You can kind of see the North American Nebula, but again, you can't see the Cygnus loop here. We're only doing like a 1-minute exposure here. So there we go. We should be almost done for target number 2 tonight.
Must not be much wind tonight. Looks like it's tracking very nicely.
Yeah, it's very steady. We'll check on the weather again later. Pretty soon the thumbnail will appear. So say goodbye to the North American Nebula. There we go. Looks pretty well framed with my custom coordinates. And now we just wait for the plate solving. Looks like it's almost there. 30,220 image stars found. Well, we're looking right into the galactic disk too, so that makes sense. There we go, 402 stars mapped. All right, here we go. The second image of the night, the Cygnus loop.
Interesting.
Cool.
Very, very nice, very clear.
Very good.
Cool.
It looks sort of like the continent of Africa there. I think it's the first time I've seen the whole thing all together that clearly.
Yeah. So I didn't mention it earlier, but specifically, this is a type 2 supernova, also known as a core collapse supernova, because the core of the star collapsed and then the outer layers imploded and rebounded in a supernova explosion. And we believe it occurred about 20,000 years ago. The progenitor star's mass was probably between 12 to 15 solar masses. And even today, we do not know where the neutron star from this explosion is. It probably wasn't massive enough to make a black hole, but if this did produce a neutron star, it has been lost. It looks pretty symmetrical here, but sometimes a supernovae explosion can occur asymmetrically, where the neutron star gets kind of shot out like a cannon. So it looks really symmetrical here. So maybe the neutron star has just been lost amongst the Milky Way, but it should be an easy find with possibly a radio telescope if it was a pulsar, but the odds of it being a pulsar where the beams go right by Earth are kind of remote. That normally doesn't happen. So this thing's about 120 light years in diameter. It's actually 3 degrees across, which for its distance translates to 120 light years, or 6 times the diameter and 36 times the area of a full moon. The debris is expanding at about 373,000 miles per hour, or 600,000 kilometers per hour for those of you that wisely use the metric system. And it heats the surrounding gas to millions of degrees. In 1904, Pickering's triangle was discovered photographically by Wilhelmina Fleming at Harvard Observatory, but named for Edward Charles Pickering, the observatory's director. And this structure right here is Pickering's triangle. I think some have tried to call it the Wilhelmina or the Fleming triangle, but it really hasn't caught on because the Pickering's triangle has been in use for over 100 years. But it should probably be rightly called the Fleming triangle. So we can call it that here tonight. And an analysis of its emissions indicate that it does contain oxygen, hydrogen, and sulfur. So the oxygen you're breathing right now came from a supernova like this. So there we go. The Cygnus loop. What do you think about that? All right, our next target, and our last target with the Takahashi tonight is another 2 for the price of 1. We'll just type in 869. It doesn't matter which one. This time we're just going to take it down to 5 minutes. That's probably even a little on the long side, but we'll just stick with 5. And we're going to go back to our ordinary luminance filter, which is just a clear filter to keep dust off the chip. So we're going to go ahead and hit acquire image and let it go. All right. So yep, our next target is NGC 869 and NGC 884, the double cluster, one of my favorite deep sky objects in the sky. As far as I can tell, we've never officially done this during an online viewing session before. I know we have done it, maybe unofficially, but we've never officially done this, to my knowledge, during an online session. So this is kind of a new one, at least for us tonight, although if you attend public observing sessions with us at the Nature Center here in Kalamazoo, we look at this all the time, especially with our TeleView refractor in the observatory. So both clusters, this is a true double cluster. They're just not close together in the sky. They are at the same distance of 7,500 light years. And again, it's 60 arc minutes across, so it's big. It's a good Takahashi target. If we ever get our new focal reducer, which we got from Fred Dutton, because he had a focal reducer on his 20-inch, which we're going to put on our 20-inch, we could probably get the whole thing in the field of view of the 20-inch, but right now we can't. So we're using the Takahashi to view this one. But maybe next season we'll do this again, but with the 20-inch, and that should be really spectacular with big old bright stars, with big old star spikes and stuff like that. So it's also known as H. and Chi Persei, or in the Caldwell catalog from Sir Patrick Caldwell Moore, it's Caldwell 14 and kind of his version of the Messier list. So this is the general location in the sky. So I pointed out Cassiopeia earlier and also Perseus. And it's right between the two. It's an easy binocular target. It is visible to the naked eye. And it's great through wide field telescopes. And it should look really, really good in the Takahashi. So there's like a 4th magnitude knot that stretches around 2 moons in diameter for the whole cluster. And the double cluster kind of represents the jeweled handle of Perseus's sword. You know, he's kind of raising his sword, and he has in one hand, he has the head of Medusa, and the other hand, the star Algol is the eye of Medusa. The Greek astronomer Hipparchus cataloged the object as a cloudy spot near Perseus as early as 130 BC. William Herschel was the first to recognize the object as two separate clusters. A little more specific detail here. It's located about halfway between Delta Cassiopeiae, which I don't quite have on the chart there, and Gamma Persei, which is around there somewhere. I'm not sure where Gamma Persei is. It's around there somewhere. If anyone spots it, let me know. But it's around there somewhere. Probably floating out here somewhere. But there it is. You can see there's a wide cluster. I don't know if we'll have this cluster in it in our field of view, but there's a kind of a sparse cluster called Stock 2 out there. Many other smaller clusters, which we might get some of in our image. Up here is the famous Heart and Soul Nebula. We've done both parts over the years during online viewing sessions. And about 25 arc minutes separate the two here, which translates to about 55 light years. But they're at the same distance, just 55 light years apart, moving in the same direction. So they clearly have a common origin. All right, let's go back to ACP, see how we're doing. So it took us a while to slew across the sky because we're looking in the opposite direction from what we were before. Because remember, we were looking over here, and now we had to slew to the other side of the meridian, all the way over there. And in fact, you can see the double cluster right there. Let's kind of zoom in on that to see if we can see it better. Yeah, there it is. This little smudge right there are the two clusters together. So there it is. Pretty good. Oh, the cloud has descended there a bit. As long as I stay on the horizon, that's good enough for me. And you can also scroll down and see a kind of weather situation here. So we can, of course, look at the specific numbers, but we can see the wind is still pretty low. It looks like it's picked up a little bit. The yellow line represents 5 miles per hour because when it does get above 5 and really close to 10, the telescope tends to get a little on the shaky side, especially right around 10. The Takahashi is not that affected, but the 20-inch is. And you can see overall, it's a pretty good night out there. It looks like it'll be a little rougher tomorrow night, so it's a good thing we're doing the session here tonight. And I just have some other weather things and moon phases on this page that, again, you're welcome to check out anytime. So we should be getting there. We'll just kind of wait for it to run its course here. You can see I'm using the acquire a single image frame here. I can also go to color series, and this is where we can do an entire night's worth of observing through like luminance and red, green, blue, hydrogen alpha, oxygen 3, and sulfur 2 filters. So we have a whole suite of filters hooked up to our camera. We mainly use the luminance and hydrogen alpha filters for online viewing sessions. We very rarely use any of the other ones because they're a little on the noisy side, at least for this purpose here, our kind of electronically assisted viewing sessions here. So we can go ahead and get rid of that because we're just going to stick with the single image plan. All righty, almost done there. 20 seconds. Well, here, I'm impatient. Let's go back to any desk. So yeah, we can see the wind has picked up a bit. It's now 4.4 miles per hour. And it looks like maybe the wind has caused the humidity to decrease just a little. And you could actually go out there at night and maybe wear shorts. Gotta watch out for those scorpions though. They'll crawl up your leg. Oh, sounds like we're done. There they go. Whoa, got a lot of stars in there. Yeah, snakes more than scorpions. That's true, Tim. Whoa, look at that. 99,851 image stars found. Holy cow. That's a lot of stars. So that's going to take a minute to process. Oh, it's done. Wow, it only used 362 stars to solve it. All right, here we go. The last target with the Takahashi tonight. Everybody ready? Here
Yeah.
we go.
Yeah.
Ta-da!
All right.
That's
Oh.
cool.
Oh, that is nice.
Very nice.
Really
Like that.
good.
Double your pleasure, double your fun.
Wide field is beautiful.
Yeah. Is
Do we
that
want
little
to
Very
verify?
nice.
Do we want to verify the star count?
Okay. Everyone take 10 hours to count them. We'll be back.
Yeah, somebody, let's divide it up into 100 squares.
Okay, I'll do this square. John, you do this square, and so we'll divide it up to everybody.
Richard, does that little line of stars coming from the left, the cluster on the left side, does that have a name? Is that some sort of a
Not that I'm aware of. These
grouping?
could be ejected members from the double cluster. Maybe it's moving
Oh.
roughly in this direction. That they could be lost stars. I do
Okay.
know whenever I look at this object with binoculars, the double cluster looks like the slash of a Q, and there's like a big circle of stars that goes all the way around that makes like a giant letter Q in the sky. I've never heard anyone else refer to it. So next time you
Okay.
go out, look at the double cluster and see if you can see the big Q in the sky.
Okay. Thank you.
Yep. And you can see another cluster over here. I'm not quite sure which one that is, but there's a little cluster below right there. Below right there. You can see a bit of dark nebulosity as well. So really a lot to see there. So both these clusters are about 12.8 million years old, relatively young. So that means all the stars in the cluster are about 12.8 million years old, which is very, very young. There are more than 300 blue-white supergiant stars in each cluster. And so the double cluster does reside in the Perseus arm of the Milky Way galaxy, more distant from the galactic center than the Orion arm, which is where we live, in the Orion arm of the Milky Way. It would appear about 4.4 times brighter, about 1.6 magnitude, if not for the thick clouds of interstellar dust in the plane of the galaxy. So this would be probably one of the greatest objects in the sky if it weren't for interstellar dust. So, bummer. If placed at the Pleiades' distance, it would span 5 moon diameters and shine 300 times brighter than they actually do today. 1/4 of the northern sky would be filled with the concentrated splendor of 600 suns. So, it's awesome, boy. But if it were closer, it could be even more awesome. But still, I'm perfectly happy with the view we have here. Alrighty? So there we go. Our last target for the Takahashi. So now, before we do anything, I'm going to do this before I forget, because some of you know I tend to forget to do this all the time. I'm going to go back to AnyDesk here, to our computer out west, and I'm going to change this to 508 and 3454, which is the information we need for the 20-inch to plate solve correctly. So I'm going to do that. And I'm going to go back to HTTP. And we're going to hit the button. Oh, we have all kinds of targets there we imaged. And I'm going to switch to the 20-inch. Takahashi to CDK. I'm going to hit that one. And we're going to switch telescopes now. Okay. So, yep, now we're going to use our plane wave CDK 20 telescope. We technically have 2 of these right now. One's in Tim's garage now because we just had the primary and secondary mirror recoated because it had faded a little bit. Our mirrors are in pretty good shape, as I recall, on our main 20-inch here, but we currently have two of these things where we have the other one up for sale. We do have a buyer, so we'll that's why we're hoping to upgrade the telescope here in the near future. So this is a kind of compound type telescope, very much like a Schmidt-Cassegrain, but of course it's a bit different in structure. This one has a more ellipsoidal primary and a spherical secondary with a lens group in the back, which is where the corrected and corrected dull Kirkham comes from. And it does have a 20-inch primary mirror. And you noticed I did type in the focal length of 3,454 millimeters. This is going to be reduced here eventually because we're going to put on a focal reducer that we got donated from Fred Dutton upon his unfortunate passing. So that'll take the F ratio down to, I forget what, maybe F4, I think. I don't remember specifically. And you can see it has an all carbon fiber construction to help minimize thermal expansion. And we have the same camera on the 20-inch that we do on the Takahashi. And yeah, caused some issues over the years with two identical cameras in the same system. But we're not going to make that mistake when we upgrade. We're going to have two different cameras. They'll both be full frame, but they'll be from different companies, different plugins, and all that sort of thing. We no longer have the on-axis guider on. We did take that off, so this is an older picture. And now the instead of the telescope kind of being on the side here, it's plugged in kind of more directly into the telescope. We were never really happy with the performance of the on-axis guider. It might have worked better with a Schmidt-Cassegrain, but it didn't quite work as well for us. And eventually we're going to put an off-axis guider on here, because sometimes we're trying to use a separate guide scope right now, and it hasn't really been terribly successful. So that was kind of an experiment that I kind of had the suspicion it wasn't going to work, but it was the cheap way to go instead of buying a massive off-axis guider. And of course, our main mount, or the mount, is our software BISC Paramount ME2. And we currently do have a Paramount ME, the previous version that we're trying to sell. We're going to sell that for about $4,800 if anyone's interested. So if you're looking for a really good mount, very cheap, we can get you a Paramount ME for roughly $48 or so $100. So there's my sales pitch for the night. So this mount has a 240-pound capacity or 480-pound instrument and counterweight capacity, both together. And it's a very good mount. We've been quite pleased with it. Okay, so let's see how we're doing. I think we should be all switched now. Let's go back to AnyDesk. And you can see my screen's all messed up now. I'm going to take a minute to fix my screen. Keep it kind of big there in case I need it. Although so far I haven't needed it. I already focused, so I don't need that. If we were doing some serious imaging, I'd probably focus again, but it should be pretty close for what we're going to do. Okay, so that's all set. Let me go back to the browser. I think. Yeah, the browser. Going to so many windows here, it gets confusing. So our next target is going to be M71, a target we have never done before. I think we'll go ahead and try 5 minutes. I think that might be a little too long, but I think we'll give it a shot. So I'll hit acquire image there. And make sure, oh, there it goes. Okay, so it's slewing now. The telescope is slewing. So our next target is M71, and according to at least Wikipedia, I have lots of books on Messier objects, and not one of them mentions this thing being called the angelfish cluster, but I've always referred to it as the Sagitta cluster because it's in the constellation Sagitta. It's the only globular cluster in Sagitta, so Why not call it the Sagittal cluster? But according to Wikipedia, take that with a grain of salt, it's known as the angelfish cluster. But I have no books that reference it as such. And it is also designated as NGC 6838 in the New General Catalog. I believe this is our most distant target so far. It's about 13,000 light years away. Does have an interesting bit of facts to it that we'll come back to. And so there it is in the constellation Sagitta. Its general position, it is inside the Summer Triangle in a very obscure small constellation Sagitta, with an even more obscure constellation Vulpecula nearby. But Vulpecula has the famous Dumbbell Nebula, which we looked at last season. You can
mean the apple core?
Yeah, the apple core. There you go. Yep. And so it is located midway between Gamma and Delta Sagittae, or 20 arc minutes northeast of 9 Sagitta. This star right here is actually 9 Sagitta. It's just not labeled on Sky and Telescope's Jumbo Pocket Sky Atlas. And you can see there is another cluster nearby called Harvard 20, or Colander 408, which is 1/2 degree southwest of M71. It will not be in the field of view of the 20-inch, at least without the focal reducer. If we ever go back and do this again with the focal reducer, yeah, we should have Harvard 20 in there. It's kind of a sparse cluster, but it would be in the field of view. But as of right now, it'll be just outside the field of view. We might see a few outliers toward the edge of the image. I'm not quite sure where it would be, though. So this was discovered by the Swiss astronomer Jean-Philippe Lois de Chasseau in either 1745 or 1746. He didn't publish a lot. He died at the age of like 33. The German astronomer, though, Johann Gottfried Kohler, independently discovered the cluster sometime between 1772 and 1779. Pierre Méchain, who was Messier's friend and assistant, first spotted it on June 28, 1780, and Messier added it to his catalog on October 4, 1780, and remarked that it is very faint and does not contain any star, because Messier often used small refractors, like an 80 millimeter refractor, where you couldn't resolve it in the stars, because as we should see later, this thing should have lots and lots and lots of stars. But William Herschel was the first to resolve individual stars in the cluster in 1783. So there's a little bit of back story on M71. All right, let's see how we're doing here. We're off, we're guiding, we're imaging, we're making progress. Let's check on the all-sky camera. Good. Another cloud. Look at that. 2 of them. Oh, there's like maybe 3. Well, at least they're really, really low. But we're going to look at something really, really low later, but not quite that low. But hopefully they won't get in the way. Okay. We've been sharing the screen there for a while. I can kind of get updated in the chat here. We apparently have one person from Brisbane, Australia. It's like, what, 8 in the morning there or something like that? Very early.
Good day, Governor.
Yes, we got folks from all over the world. Pete mentioned there's a roadrunner busy eating scorpions. Well, maybe. We wonder about that. We do get the occasional roadrunner out there. And we try to adopt owls around the observatory to keep the rodent population down. They're very good at that, by the way. Kind of a quiet crowd. Would love some questions. What's that, Tim? Oliver? That's what you guys named the owl? Owliver? Has not been back to Jim's? Okay.
Hey, Richard, it's Eric.
Hey, Eric.
I am out in the field with the telescope trying to image some Orion things while I'm watching you.
Is it clear?
Well, it started out clear and I see some clouds now, but of course it's Michigan. You never know, right?
Okay.
But it seems to be it's thinning. So I can still see it, sort of.
Pete, you'll have to share a live view of your all sky camera. We'll
Yeah,
the weather looks like at your place.
yeah, I can, you want me to share my screen real quick?
Oh yeah, let me turn that on for you. There you go. We should be almost done with our image though. We got a few minutes. Seconds anyway. Oh yeah.
Oh,
Rolling
Eric,
in.
where are the stars?
They're there. You can see there's the Pleiades. You can see kind of.
there we go.
Okay, how do I stop sharing?
You
Whoops.
hit the red stop sharing button.
Is it still sharing? Oh,
Yes, it is. Here. Oh, here we go. Ta-da!
boom.
I have the host control power. All right, let's see how we're doing. We should be almost done. I haven't heard any bunks though. Oh no, we're done. I think. Oh, there it is. Okay. The thumbnail just popped in there. Now we wait for it to count stars. Hopefully it's not too trailed because again the guide scope hasn't been working out too well.
It was fairly short exposure.
Yeah. There we go. Wow, it's probably solved 229 stars. All right, here we go. Our first target of the night with the 20-inch, which again is a first-time object. We've never done this before during an online viewing session. Here we go. Ta-da! Well, that's pretty good.
That's neat.
Nice.
It is very good.
That is very nice.
Yeah.
I'll give it a cute rating.
Be waiting.
Does that start with like butt ugly and go all the way up to gorgeous?
Well, I hadn't thought of that, but that could be. And cute's good.
Okay.
Cute's good.
Hopefully cute's a little better than passable. You know, maybe. That's passable. It's kind of cute.
Hey, Richard, what's causing the halos on some of those brighter stars in the top left?
I'm curious. I was wondering about that. There might be some thin haze out there. There was earlier today, but I'm not quite sure myself. I've never quite seen that before. Maybe our mirrors get a little on the dusty side. I'm not sure.
Would that be caused by dust or some sort of moisture on the mirror?
It's definitely not frost.
It doesn't look especially hazy, but it sure did earlier today. But I think it's cleared out enough to where it shouldn't quite look like that. So I don't know. So at about 13,000 light years distant, M71 spans 27 light years, or about 8 parsecs, making it one of the smallest known globular clusters. It has a mass of about 53,000 solar masses and a luminosity of around 19,000 suns, which again is fairly low for a globular cluster. It has an estimated age of 9 to 10 billion years old, which again is relatively young for a globular cluster. It also lacks RR Lyra cluster variable stars that are common in most globular clusters. Our Lyra stars are standard candles like Cepheid variables. They can be used to measure distances, again, much like Cepheid. They're just not as bright as Cepheid. So they really only work for nearby objects, not, distant galaxies. It has about 17% of the sun's metal content, the metallicity, which is unusually high for a globular cluster. So all these weird facts. So that's why for many decades, at least until the 1970s, M71 was considered a densely packed open cluster, much like much like M11, the wild duck cluster, which is kind of nearby. Today, M71 is designated as a very loosely concentrated globular cluster based on plots of its stars on the HR diagram, which looks very characteristically like a globular cluster as opposed to a open cluster. And the velocity of this object shows that it is a disk cluster. It stays in the galactic disk rather than merely passing through it. So let me go back here, because normally, here's a diagram of the galaxy. So here's the galaxy seen from far above, where we see the sun about 2/3 from the galactic center. Oh, looks like half here, but it's supposed to be 2/3. And typically you find globular clusters in what's called the galactic or stellar halo. But M71 is very unusual. It is right in the disk of the galaxy. So that might be one of the reasons why it has all these weird statistics, like it's not very big, it's missing our Lyra stars, it's young. So again, it's a mystery. This thing didn't form in the disk because it's much older than the disk. Disk stars aren't that old. They're maybe upwards of 5-6 billion years old, not 9 to 10 billion. So there's a lot we don't know about M71. It's basically a very, very unusual and different globular cluster. I always like to observe it because it's right in the disk of our galaxy. So there's lots of stars you have to look through to see this thing. So it's very different compared to the other globular clusters that you can either observe or image, as we've done here. And it's our first time doing this tonight. But why they call it the angelfish cluster, I don't know. To me, it looks like it's the Sagitta cluster. All right. Any other questions? Okay. Scroll down here. We're going to do another new target. This is one I've had trouble doing. First, I could never find a guide star with the on-axis guider. And then this thing tends to be so low that I always tend to get trailed stars with the guide scope. So we'll give this one a shot. So this is a new target for our online viewing sessions. We're going to stick with 5 minutes with the luminance filter. We could use the O3 filter, but it would look pretty noisy, at least for a single image. So we're going to stick with the luminance filter, which should look a little bit better. And we'll go ahead and hit that. So you can see we're minus 20 degrees declination. So we're going way down there. Our last two targets are kind of way down there. So debuting tonight for an online viewing session is NGC 7293, the Helix Nebula. So again, we're way far south of the galactic equator, or the celestial equator. So minus 20 degrees. 7.6 is pretty bright for a planetary nebula like this, but it is big. It is nearly the diameter of the full moon. So its surface brightness is very low. And at 650 light years, it is the nearest known planetary nebula. Only 650 light years away, so it is close. It's also known as Caldwell 63 in the Sir Patrick Caldwell Moore catalog, because it is a pretty famous object. Here's its general location, and for many of us in Kalamazoo, this is kind of like no observers territory, because it's very low in the south, where there's either lots of trees or lots of light pollution that we have around here. So We don't often get to observe this part of the sky very well from at least the lower half of Michigan where we are. Definitely not the nature center. This part of the area is really hosed from the nature center, but we're looking just south of Aquarius here, the water bearer. This little feature up here, which kind of looks like a 5 pattern or something like that, kind of like a Y maybe. That's called the water jar. I mentioned Capricornus earlier, which was behind the bird perch on the all-sky camera. And the single bright star down here is kind of the famous Fomalhaut, which does have a very dusty disk around it that you can see in Hubble Space Telescope images. And I've never really gotten a great view of Pisces Austrinus myself. So here's where we're looking on Sky and Telescope's Pocket Sky Atlas. This thing is right on the edge of charts, so that's why I had to kind of frame it like that in the view here. So there's the general position of the Helix Nebula. It's about 11 degrees northwest of first magnitude Alpha Pisces Austrini, or Fomalhaut down here. 11 degrees is a long star hop, though. But it's more like 1 1/4 degree west of the 5th magnitude New Aquarii, which I don't believe is in my field of view here. It's very difficult to get a good view of this with the Pocket Sky Atlas because of the way they divided the chart up. This was actually discovered by the German astronomer Carl Ludwig Harding in or around 1823 using the 8.5-inch reflector. All right, let's see how we're doing. We already have a guide star. So it didn't have to do a meridian flip. That's how we got to it so fast. And we're guiding, so hopefully it'll be not too trailed. Because again, I've had trouble doing this one. Before with the on-axis guider, I couldn't do it at all because I could never get a really good guide star. And with the guide scope we tried to use, it just doesn't lock on good enough. We got too much flexure or wind bothers it or combination of all those. Let's go back to the all-sky camera and see how we're doing. You can see Capricornus here behind the perch. It'll be a little better. And that's Fomalhaut, I believe. So we're like down over here somewhere. Not quite sure where it is. It's hard to tell with the perch in the way. It's a major obstruction, but we got to have the birds. We got to give the birds something to sit on besides the dome. Okay. Let's check. Let's do a weather report. Oh, it's back down to 3.7 miles per hour, the wind that is. I believe the humidity has ticked back up a bit. That makes sense. Guide star looks pretty steady. Not flopping around any. So maybe we'll get a good image. I hope so. Oh, and here you can see ACP itself. You can see I'm logged in there. There I am. And again, if you're a member, you can use the remote telescope. Hopefully pretty soon with the upgrades, we'll have it better than ever, where you can just let it run. Right now, the guiding tends to be a little dicey here and there, but once we hopefully get everything upgraded and fixed, it'll work better than ever. And you can just let it run all night and sleep. Get some good images. We'll go back to the screen here with ACP. We're almost done. Looks like someone signed off from Maryland. So it is great to have folks join us from all over the world for these. There'll be a lot more activities that I'll mention later that you can join us for. I mean, there's lots of stuff coming up, and I'll explain why. And Pete says the reducer will drop the scope down to f 4.5. That sounds pretty good. I knew it'd be f4 something. I just couldn't remember what. Oh, now we're 5 seconds past.
It will be a light
How
bucket.
does that work out? What's that?
It'll be a light bucket. It'll suck in the photons at a 4, 5, and 20 inch.
Yeah. I just hope it's not trailed. Ooh, that looks pretty good. Now, it shouldn't have to count too many stars. It's kind of sparse down there. Counting. This is why we need a new computer, too, so it can count faster. Maybe it takes longer when there are fewer stars. Oh, there we go. Only 2,246 stars found. All right, are we ready? Let's see how this worked out. Drum roll. Ooh, that's pretty good.
Oh, nice.
That's a
That's
great
very
picture.
nice.
Yeah, it does look.
Excellent.
That is a big donut.
Yeah, and I don't see a lot of trailing either.
No, that's pretty good.
Mhm.
This is the best image we've taken of this thing so far, of this thing.
I don't see the halo effect either.
That's really neat.
Yeah, lovely.
All right, so the true physical size of this object is 2.87 light years. It has an estimated age of 10,600 light years, and it's expanding at 31 kilometers per second. The progenitor star was about 6.5 solar masses. Well, you would think a star that massive would go supernova, but usually got to be at least 8 solar masses, I think, to really go supernova. So 6.5 is an upper level kind of medium mass star like the sun. Of course, 6.5 times more massive though. The white dwarf, which could be this one, I'm not really sure, right in the center there, has a surface temperature of about 120,000 Kelvin. And it has a mass of 0.57 solar masses, so roughly 60% the mass of the sun. And it shines at about 13.4 magnitude, but may be variable. That's interesting. It glows with the light of excited nitrogen and hydrogen atoms. And quite famously, from early Hubble Space Telescope images, it contains about 40,000 cometary globules, or knots, and there are 2 possible explanations for these. It could be shadowing, extended shadows cast behind the globules, surface of which are photoionized by ultraviolet radiation or by ionized ablation, created by the outflow from the central star, sweeping past slowly expanding systems of clumpy globules. But if you do think about it, just do a search for Hubble Space Telescope Helix Nebula images, and you'll see the images of the cometary globules. But with a good long exposure, you can capture them yourself. And once we can get the remote telescope to guide reliably, we'll get, at least in this region, we'll get some really, really good images of this thing one of these days. So there we go, the Helix Nebula. All right, let's go to our final target of the night. This is one we have done a few times, maybe twice before, maybe 3 times, but we don't do it every season, but we do it often because it's one of my absolute favorite galaxies in the sky. and it's NGC 253. I think we'll go ahead and stick with 5 minutes with the luminance filter, and you can see we're even lower now, minus 25 degrees in declination. So I think we're ready. Let's go ahead and acquire the image. So here we go. NGC 253 is the Sculptor galaxy because it's the major galaxy in the constellation Sculptor. It is pretty bright, 8th magnitude. I have heard some reports that people with really exceptional vision under very dark skies have glimpsed this thing with the unaided eye. I'm skeptical of that. My eyesight is nowhere near that good. I did try to look for it years ago at the Okie Tech Star party, but apparently that was kind of a hazy year and I couldn't see it. But if you could see this with your eyes alone, it would easily be the most distant object you could ever see, because this thing's 11.4 million light years away. And on its long axis, it's nearly the diameter of the full moon. So it's big in the sky. And it nearly fills the chip of the CDK-20 with the S-Big camera, because it's roughly 30 arc-minute squares, the field of view of the camera. So, boy, I haven't talked this long in a while. My voice is going out, so bear with me here. I'm rusty. So this is also known as the Silver Coin Galaxy. You may have heard that name here and there. Here's its general location in the sky. So we were kind of over here with the Helix Nebula, like right around here, I think. Now we've kind of went down a little further south and a little more toward the east for NGC 253. So we don't have to slew that far. I don't think we have to cross the meridian. I hope not. Here's its general location in the sky, right near the South Galactic Pole, coincidentally. Located about 4 3/4 degrees northwest of the 4th magnitude Alpha Sculptoris, right here. Or 2 degrees northwest of the South Galactic Pole, as mentioned. It was discovered by Carolyn Herschel in 1783, while, of course, scanning the sky for comets. So some interesting facts about Carolyn Herschel. She was born in Hanover, Germany on March 16, 1750. She's the 8th child and 4th daughter of Isaac and Anna Herschel. She was struck with typhus at the age of 10, which stunted her growth. She never grew taller than 4'3". And for that reason, they considered her kind of unsuitable for marriage for some reason. So she was really kind of she became more kind of the family servant, which she hated. But she eventually immigrated to England to join her brother William in August of 1772. And at first, she was like the record keeper for him.
Not sure how it's doing it.
I'm sorry? What was that?
Oh, sorry.
Don't interrupt me when I'm talking, Eric.
Sorry.
That's why you shouldn't join us from the outdoors, because you're not paying full attention. Okay. So at first, she was the note taker for her brother William as he made his observations, but eventually he kind of turned her loose, let her go on her own, and she began scanning the sky with her own telescope looking for comets. And from 1786 to 1797, she discovered 8 comets. And in 1787, she was granted an annual salary of 50 pounds by King George III. She became the first paid female astronomer. So quite historic. And she dang near lived forever. I think she almost made it to 100 years old, which is pretty good back in the 18th century. Let's see how we're doing. All right, we got a guide star. We're imaging. Looks like it's been a pretty successful night. Thank goodness the weather got better and the skies improved a bit. Well, while we're waiting, let me talk about a few other things here. We'll just get this stuff out of the way. You can, of course, join the Kalamazoo Astronomical Society and learn to use the remote telescope yourself if you live in one of these counties. Maybe one of these days we'll open it up to more places. But right now, remember, we're all volunteers. This is not a commercial endeavor. And if we are afraid, at least at the rate we're charging now, which is only $50 a year plus membership, that we would get overwhelmed with requests. So we only keep it open to members in Southwest Michigan in one of these counties in red. If you were kind of just outside this region, we could make a possible exception for you. You'd have to be kind of an active member. You know, you have to show up once in a while, at least on Zoom. You just can't join and use the scope, and we never ever see you or hear from you again. You got to be somewhat active to get permission from outside the area. But you can join the telescope. I'm sorry?
Are these the different counties in Michigan?
Yes, these are the various counties in Michigan, and if you're in one of the ones in red, you are eligible to join the club and use the telescope.
Lower Michigan.
Yep, this is the lower peninsula, obviously. Looks like a big mitten.
I'm having trouble reading. Is Van Buren in there?
It is. That's
It
just
is.
west of Kalamazoo County.
I don't live there, but I don't live there anymore. But I just wondered. I'm in North Carolina, so you know, I mean, I'm able to participate. But I was just curious.
And of course, be sure to join us for our next online viewing session. I forgot to copy the links, so I don't know if Pete or someone can help me out. Copy the registration link for the next session and post that into the chat. I forgot to put those together. It's our first session, so I haven't done this in 9 months, so I'm a little rusty. Plus, I'm working on other things for the club right now. So be sure you join us on December 13th for our next online viewing session. If we don't put the registration in the chat, just go to our website, kasonline.org, and you shouldn't have a hard time finding it on there. You can scroll through the calendar on the main page or go to the online viewing session page. Oh, thank you, Pete. Or, you know, there are plenty of ways to find it. And if it is cloudy on December 13th, our cloud date is December 20th. Hopefully we won't need it. We didn't need any of the cloud dates last year. Last year was like the perfect season. And of course, if you are already a KAS member, you do not need to sign up for this. You get the same emails, but you can also, if you are not a member, or you know you're outside the area, you can sign up for our online viewing session email list. I'm not sure the QR code works. I put this together last year, but I don't know if those things expire. So you can try to use the QR code, or you can just email me at kasonline.org to request to be put on the online viewing session email list. So you'll get reminders about the session, registration, and YouTube links, links to download the images, which you should already have if you're on the list now, and of course notifications of postponement or, heaven forbid, cancellations. But hold on there, hold the phone. It sounds like our image is done. There it is. So, oh, I couldn't find any matching stars. Maybe it's a little too far south, but here we go. Our last image of the night, NGC 253, the Sculptor Galaxy. Here we go. Pretty little trail.
Very good.
Pretty good.
That's nice.
It looks really nice.
Wow.
Perfect.
That is awesome. Very awesome.
Silver coin galaxy. Nice.
That's it. Yep.
Is this a bar or a non-bar spiral
It,
galaxy?
it is a barred galaxy.
Oh, okay. All right.
It's a little hard because it's nearly edge on, but yeah.
Yeah. Well, that's why I was
Still make out
asking.
the arms.
So,
If I had to guess, I think the bar maybe goes this way. At least one of them does. The other one's too hard to see, but it could be this way too. It's hard to tell because it looks like it might spiral out from here at the end of a bar and go kind of out this way. But boy, it's tough to tell from the image. So I tried to do a little bit of research of how large this is. I really couldn't find any references, so I did some good old-fashioned trigonometry, and I calculated a diameter of 91,200 light years, which seems pretty reasonable. So take that with a grain of salt, but I think that's reasonably accurate that this galaxy is about 91,200 light years across. That's very comparable to the Milky Way. Milky Way is a little bit bigger. And this is, again, somewhat a barred spiral as well as a starburst galaxy. So somehow this galaxy either had a close encounter or, kind of like a gravitational harassment from another galaxy, or it absorbed another galaxy, which disrupted gas and dust in the galaxy and made it do all kinds of star formation, which is why we call it a starburst galaxy. It's undergoing a great deal of star formation. This does have a supermassive black hole of about 5 million solar masses, about twice the mass of the one in the Milky Way galaxy. And NGC 253 is part of the Sculptor group of galaxies, which is a relatively loose group of 13 galaxies and one of the closest to the local group of galaxies, which contains the Milky Way and the Andromeda galaxy. So there you go. That is our last target of the night. We'll go ahead and leave that on the screen here. So let me go ahead and wrap things up. So again, be sure you join our online viewing session list if you are not a member and want to be kept updated on when the sessions are coming up. Now, I mentioned I've been very busy lately because next year is a special one for the Kalamazoo Astronomical Society. Next year is our 90th anniversary. We were founded in 1936. We are the oldest and currently the largest club in Michigan. So we have all kinds of special events planned for next year. I don't have time to go through them all, but here's one coming up. Be sure you join us either in person at the Kalamazoo Area Math and Science Center or on Zoom for one of the biggest guest speakers we've ever had, Professor Sarah Seeger from MIT. She's a very, very well-known astrophysicist, and she'll be giving a presentation about Venus as a potentially habitable planet. So we are very excited about that. That's a great way to kick off our 90th year. So again, Pete, if you could, put in a registration link for that in the chat. So if you can't join us at KMZ, the Math and Science Center, be sure you join us for Zoom for that one. That's going to be an excellent talk. She is a great speaker. And then also, if I can get the thing to advance here, our Introduction to Amateur Astronomy lecture series, famous the world over, will return next year starting January 17th. So again, if you can go to our website, go to the activities menu and look for the Intro to Amateur Astronomy page, or if Pete could be so kind again, to put a link to the web page, and from there you can register for the sessions on Zoom. So I have a form on the page that you can use to directly register for the sessions on Zoom. And as we mentioned before, if you attend all 5 sessions, because it's a 5-part lecture series, you will receive a certificate of completion in the mail. So some people have attended 2 or 3 times. So if you've done the series before, you can do it again. And if you don't have a certificate, you can attend the series and get one, but only then will you be a full-fledged amateur astronomer? You can't be an amateur astronomer without a certificate. Well, okay. So here is the link to download tonight's images. If you are a member or you're on the online viewing session email list, you already have this link, which doesn't work yet, obviously, because we just took the pictures. So I haven't had a chance to download them yet. But I'll try to get to that tonight, because tomorrow I'm going to be grant writing to pay for all of our activities next year. So if someone can type this down real quick and put it in the chat, please do, because again, I apologize, I forgot to have the links handy to copy and paste into the chat. So all you have to do is go there to download the images tonight. And again, I might not have the images until maybe this coming Monday or maybe Tuesday. I'm hoping to get them online tomorrow, but things get busy, life happens. So don't email me until at least November 18th saying, hey, where are the images? I can't find them, because maybe I haven't finished processing them yet. I'm only human, folks. So there we go. That concludes the first online viewing session of the season. I even finished up 2 minutes early. I think last season I went like 10 minutes over or something crazy like that. So thanks again for joining us, and we hope to see you again on December 13th.